Hello class, good day once again. Welcome to our session. Today we are going to discuss another example for the integration by substitution for the trigonometric functions. So last time I give you one example for this part. So last time we solved one problem that is using single substitution. So today I'm going to give another one. This is also a single substitution. So our second example, so we're given the integral of 1 plus tangent theta, and this whole thing here is raised to a power 5, then multiplied by secant squared theta d theta. Okay, so that's our given. So now we are going to identify what is our u, okay, and also what is our n. So in this given, our n is equal to 5. So as mentioned last time, n can be found outside the parentheses as the exponent. So in this case, we have this parenthesis. So the exponent is this one, the 5. So this is our n. Then our n plus 1 is equal to 6. Okay, so as mentioned last time, we have to use the formula, the integral of u to the n du. So we have to derive this one, and once we have derived this, so we have to use the equivalent u to the n plus 1 divided by n plus 1 plus c. Okay, so from here, so we can let this part here as, okay, so we can let this as our u. So we let u be equal to 1 plus tangent theta. Okay, so after that, so this one can now be written as integral of u to the 5th power. Okay, since we let 1 plus tangent theta as our u. Okay, so we can now rewrite this as u to the 5th power. And the next, you have to find out what is the secant squared theta d theta, this part here, so that we can replace this with an expression that contains our du, so that we can get this form, u to the n du. Okay, so how to find that? So we are going to differentiate, no? Or take the derivative of this u. So our derivative of u with respect to, so this time class, it's no longer x, because our argument here is an angle, so we have to use d theta, because our variable here is the angle theta. Okay, so derivative of 1 is a constant, so that is 0. And the derivative of tangent theta, so what is the derivative of tangent theta? From our differential calculus, the derivative of tangent u, if you have, if you can still remember in our calculus, if you have derivative of tangent u with respect to x, so this is equal to secant squared u times the derivative of u with respect to x. Right, so that is our formula. So we can follow this. We can use this formula. So derivative of 1, which is constant, is 0. So derivative of tangent theta is simply secant squared theta times the derivative of theta with respect to theta, which is equal to 1. So this part here is just equal to 1. Okay, so our du over d theta is equal to secant squared theta. So our goal now is to find what is the secant squared theta d theta so that we can replace that in terms of du. So from here, to solve for du, so we can multiply both sides by d theta, okay, or multiply both sides by d theta, or cross multiply d theta, so that we have du equal to secant squared theta d theta. Okay? Any question? So exactly this one. So this is what we have exactly. So we can replace this by its equivalent, which is this expression secant squared theta d theta is simply equal to du. Alright, so substituting this, so instead of writing secant squared d theta, since this is equal to du, so you just write it here as du. Alright, then this is now in the form of u to the n du. So we can now use this formula. So this is equal to u to the 6th power divided by 6, then plus c. Okay? So this is equal to 1 over 6 times u to the power 6 plus c, equal to, substituting the value of u. So since our u is equal to 1, so this is our u. That is equal to 1 plus tangent theta. So substituting, so this is 1 plus tangent theta, then raised to a power, this one, 6, then plus c. Okay, so this is our answer. I hope you were able to follow the steps class in arriving this answer. Okay, so that's all for this example. I'll give you another example in our next video. Thank you very much. Bye.